In section 2.5, we're going to talk about measures of center. And at least some of this information is going to be familiar to you, I'm pretty sure. Measure of center is a value that kind of gives us an idea of where the middle of the data is. There are several ways that we can do this, a couple different statistics that we use. And the first and most important is the mean. Okay. Now, if you're familiar with the fact that there are different kinds of means, specifically we're talking about the arithmetic mean, which is what we typically call the average. Like I said, this one's the most important measure of center. We use it in other calculations very frequently. It's the one that most of the population is familiar with, so it's pretty important. And I think you know how to calculate the mean, but just in case, a little reminder, you add your data values together and you divide by the total number of values that you have. The symbol that we use for a sample mean is X bar. Okay, I'm sorry for the fuzziness of this symbol, but it's an X with a bar over the top. We pronounce it X bar. And if we're talking about the mean of an entire population, then we switch symbols and we use this. This is a Greek letter mu. So it looks a little like a cross between a U and an M, and that's kind of what it is. It's a mu. All right, the second measure of center is the median. We talked about the medians earlier when we talked about location of the data. We talked about the fact that this is the middle value. If you arrange your data from least to greatest, the number in the middle is the median. And so this is kind of review of a previous section, but sort the data, find the data that's in the middle. If you have an odd number of values, odd number of data points, then the median will be the number that's exactly in the middle. If you have an even number of data points, then you need to find the two numbers that are in the middle and then average those together. The symbol we use, and again, sorry for the fuzzy symbol here, but this is X with a tilde over the top, X tilde. This is not a super common way of denoting the median, but you do see it occasionally in some textbooks. The third measure of center is the mode, and this is the data value that occurs the most. Okay, so if you have a data set with a lot of repeating numbers, then you are going to have a mode. Now, some data sets will only have one mode. There'll be one value that occurs more times than any other value, and that will be the one mode. But it's also possible to have more than one. So, if you have a data set with 100 things in it, and there's two values that show up, let's say 5 times each, okay, then that would be a case where you actually have more than one mode. Or it's possible that you might have data where none of the values repeat. You have all unique values, in which case you'd have no mode. So if you do have the two-mode case, we refer to that as a set that is bimodal. If it's more than two, we just call it multimodal. And if you don't have a mode, if none of the values repeat, then we just say no mode. Generally speaking, when we're talking about samples, the larger the sample that you take, the closer your sample mean will be to the true population mean. Now, that's assuming that you're collecting random samples. You're using, sound sampling techniques. As long as you're doing that, then this should hold true. To give you just some instructions on rounding, when you find means and whatnot, sometimes you have to round. So generally speaking, we're going to round to one more decimal place than we have in the original data set. And this here, mean from a frequency distribution, this is probably the one thing that is brand new. You've probably never done this before. So if instead of having the actual data listed for us, if instead we have a frequency distribution, a table with the frequencies, which we have created earlier in this chapter, so that's something hopefully you remember. There is a way that we can still find the mean. We will multiply each class midpoint, which, if you remember, we found class midpoints when we did the frequency polygon graphs. So you take the class midpoint, multiply by the frequency, and then we'll add all of that up and then divide by the number of data values, which would be the total of the frequencies. So Here's an example to hopefully make this make sense. Here we have some classes on the left in this frequency table, and then the frequencies on the right. So what we want to do is take the midpoint of each of the classes. So if we try to find the midpoint of 0 to 9, that would be 4.5. And the midpoint from 10 to 19 would be 14.5. And 20 to 29 would be 24.5. So in this table, they're all very consistent, fairly easy to find. And what we do is we take each of those values and multiply by the frequency. So the 4.5 gets multiplied by 4, the 14.5 gets multiplied by 6, and so on and so forth. So we're getting all of these products here on the right hand side, and we're going to take all those products and add them up. So when we do that, we get 449. Okay, so that's the sum of all of these products. And now what I want to do is I want to divide that number by the total number of data values that we had, which we can tell by just adding the frequency side, the frequency column. Okay, so it looks like we had 22 data values there. So 449 divided by 22 gives us 20.4. Okay, so now this is a case where what we found is actually an estimate. It's not 100% likely to be. Let me say it's not likely to be 100% accurate, because the only way to really know for sure is to have all the data values, and we don't. We just have a summarized version in this table. So this should be relatively close, but it is not going to be the exact value of the mean for the original data set. We'd have to have that data set in order to know. All right, so in this section, a couple practice problems. Like I said, in particular, I think doing the frequency table one is probably the only one that's really new. So I would at least work on that one, but the others would be good practice for finding means and medians, etc. In section 2.6, we're going to talk about skewness and how that relates to the mean, median, and mode. Basically, what skewness is kind of looking at the shape of the graph and identifying how that shape of the graph connects to the mean, median, and mode. So if you have a graph that is perfectly symmetric, so if you could draw a line down the middle and the graph looked exactly the same on the right hand side and the left hand side, so that if you folded that graph in half over that vertical line, the two halves would pretty much lay on top of each other. That would be a symmetric distribution, a symmetric graph. That's going to happen sometimes. We do have data sets that do that. But if it doesn't happen, we call that data set skewed. So let's look at some examples and see if we can kind of figure this off. In general, when we name these, and this may be a little counterintuitive, the side with the longer tail is the side that we name it as. So like if you have a longer tail on the left, we say it's left skewed. If the longer tail is on the right, we say that it's right skewed. Okay, so this would be an example of a symmetric graph. Okay, I have the data listed up at the top, and when we put that data into a histogram, we see that we have absolute perfection on the symmetry on either side of that tall bar at 7. Everything looks exactly the same to the left and to the right. So what this means is that the mean and the median are exactly the same. Okay, if you have data that's perfectly symmetrical, then that means that you have the mean and the median exactly the same, and also have those two values equal to the mode. Here, data is skewed to the left. So if you kind of just trace out the shape of this graph, we see that it peaks further to the right, and the longer tail is on the left-hand side. And remember, we name it according to the side that has the longer tail. So this is left skewed. In this distribution, this skewed left distribution, the mean is left of the median. It's less than the median. So remember that the median is the value that's in the middle of the data. So in this case, the middle of the data would be would it be 6.5, I think, probably right in between 6 and 7. And then if you pause for a moment and calculate the mean of these values, we'll see that the mean is a little bit less than that 6.5. Okay, so If the mean is to the left of that, to the less side of the median, then we have a left skewed distribution. Also point out that the tallest bar is going to be the mode, right? Because that's the one that happens the most. And notice that our mean and our median are both less than the mode. Here we have a right skewed distribution. We see that the longer tail is on the right hand side. So on this one, the mean is to the right of the median, and both of those values are going to be to the right of the mode. The mode will still be 7 here. Alright, so for homework in this section, basically you're just kind of identifying what skewness you see in different graphs, and I think there's a couple questions in there about, is the mean less than or greater than the median on this picture, etc. So should be some relatively simple practice problems to get you going on this, and let me know if you have any questions.